Hi student, Architecture 122. Today we will discuss about Chapter 4, Conventional Orthogonal Terminology. In this one, we need to know a few definition before you start with drawing on orthogonal. First of all, I need you know the scale plan, elevation, section in architecture meaning. When you have one drawing, you should know about two-dimensional or three-dimensional with the smaller scale. Scale plan, that means you draw the plan with the scale. Architecture scale, you usually see 1/4 inches equal 1 feet 0 inches, 1/8, 3/16, 3/32, so on. So you need to use the scale to draw the manual drawings. Elevation and the section is some of the drawing. You can see the height from the building. Elevation, you can see many faces. For example, you see on the west side, east side, north side, or south sides. You can see the height from the building. You call that elevations. And the sections is some kind like similar with elevation. That means you need to show the height from the building. However, the section is go more detail with the structure. That means you can see the detail from the wall, from the roof, from the slab, from the everything inside from the building. When you cut somewhere in elevation, and that's one you call that a section, because in there you see all of the material structure you use for that building. So now buildings have described using for orthogonals. That means the right angle. You look straight on there and you have two-dimensional drawing system, and you call that orthogonal drawing. It's the knowledge of orthogonals, conventions, and the roughest symbols is necessary for architectural drawing and presentations. You need to know two main things. They call that horizontal plane. They always parallel to the level crab. Second one, they call that the profile elevation plane. They always at the right angles. That means 90 degrees to other planes. So if one project you have many planes, but the one is 90 degrees with the other one, you call that profile elevation. This is one example for that. You see, this is one project. If you look on the top one, you can see this one look like this. And when you look this one, you can cover on the plan, and you call that horizontal plane. That means the plane you see right here always parallel to the round one. This is the round one where you stand up to look at the projects. So now if you look in front of the building, you look at the side right here. For example, say right here, you look straight to the building, 90 degrees to the building. That's the plan. You see everything from the front face of the building is 90 degrees. And this one you call that orthographic projection drawing. That means 90 degrees with the crown line. Okay. And if you go another side, for example, you stay here to look at this side from the building, or the other side in the back one or the rear one, something like this. And this side, you have another plane perpendicular with the project plane. So you have three of them. The first one you call that horizontal plane, is the plane parallel with the rounding where you stand up to look at the projects. The second one is you call that projectional plane. That means the plane is 90 degrees. This plane you see that is 90 degrees with the ground one, and with the other side from the projects. So that means the ortho means that the right angle Orthographic projection refers to transfers of the image created by perpendicular projector rays striking a transparent glass plane. The rays are always parallel to each other. You have many rays go with the projects and it's always parallel to each other. The front elevation plane is always vertical and 90 degrees to the level ground, like I told you before. The principal planes is along with 3 additional adjoining planes back or the rear, left, profile, and the bottom. From the closed glass box, you can see like that when you look at the planes. On lines, upside and projection lines are perpendicular to the principal planes. They see an image of the projects projected. On 3 principal planes are perpendicular to the another. Each 2-dimensional principal planes can be classified as the picture plane because it records the picture image to the project. So that means around the project you can look on the side from the projects perpendicular with the project plane, and on of them like the image from the projects. This is explained more, for you can see that the principal plane of projection. When you look at the top, you know that this one is the horizontal plane, and the plane right here you can see that's the plane on the top one. You look down to the projects, that's what you call that horizontal plane. And in front of that, the line, this is your eyes. You look at the projects by many rays, and you look at the projects right here with the image line. All lines on the side from projection line perpendicular. This line is perpendicular. This the plane is perpendicular with the principal plane. The principal plane is on the top one, and this one is perpendicular with this one. You can see the ray line like this, and the top one like this. On 3 principal plane, the other one also perpendicular to the one together. That means this one perpendicular with this one, and the rear one or the back one perpendicular with this one. So we have another one on the picture plane because it's record the picture image to the projects. This one record for this side, this one record for this side. You have the another 2 sides to record for the other side from the projects. More definition you need to know: a folding plane line is the intersection of any 2 principal planes. If you have any one intersection together, and you call that the folding plane line. If the transparent glass box is open to its folding plane or hang the lines, it will become a 2-dimensional surface. And on the elevation plane are rotated to become the part from the frontal elevation plane's extension. You sometimes can see the rapid line symbol for the folding plane. They usually show the hang lines like this: dash, the long dash, and 2 small dash, the long dash, and 2 small dash. Another definition is orthographic drawing are true size and the true shape views that are related on 2-dimensional surface. If you have 2-dimensional surface with the true life and the true shape views, and you call that orthographic drawings. When 2 planes are perpendicular to the 3rd plane, any points in the space will be seen twice an equal distance behind the 3rd plane, and the proper distance can then transfer with the projected line from the top to the horizontal view to the side for the profile view. Example for you can see that's orthographic views. If you have the simple projects like that, and on the top one, you look from the top one, you can see the plane like this, and of course this plane is horizontal plane with the round one. Now if you look here in the front side from that one, you can see the face is this one, and after that you see the face is this one. and the height from that is low, like this. If you look at here, you look at this one. This is the way how do you draw for the side view. This is the side view. You stay right here, you look at this one. You draw this one like the line like this for 90 degrees, and after that you draw vertical line like this when you do transfer line. And if you stay this side, you can see this part is this one here. And after that you see this middle one right here, lower, and you see the other side right here is this one. So that's why you see three parts separate, depend on the front side or the side one when you look at the projects, top, front, and sides. So that the simple projects when you see that. And the way how do you draw, for example, from here to here, they call that A. The point A is the point A right here. This line you can call that contraction line or project line. You straight like this. For example, right here you create a line straight right here, and you call this a project line. And the distance K, you can assume like that on the distance K right here, and you start the point A right there. Same distance, just different angle. You twist that for 90-degree angle, and you start A right here. How long for this one? You start how long for this one. How high from this one? You start the other one the same high right here from the building. And you start, for example, this point, you have this one because A start right here. And how long for this one? You do how long for that one. Continue with that one. You can measure this one by this one. You see that? And finally this one is that one, and you draw like this. So now it's the side one. For example, you have the box. Look at this. This is the box. This is the box. Okay, it shows 3 dimensions from the object. You can see the box right there. The top one right here, you open that and you can see the top one look like this. You open the box. This is the top face, the top one. You see like this. Now this is the front face. You can see like this. And it is the side face. When you open the box on this side, you can see this one. Okay, exactly this one, but you show this one 3-dimensional. This is one example, so you can see the section and elevation. For example, you see this one elevation. Why? Because you see the height from the house. You see that the height from the door. You see the height from the frame. You see the height from the top one right there. And the chimney, the height from the chimney. So everything you can see the height from the building, you call that elevation, and it is the front side from elevation. So now you see exactly similar with elevation. That means you see the height from the building, but you have more structure from the building. For example, you see the stairs section cut, you see the column, you see the wall, something detail from the window, and you see on up the ceiling high with the the ceiling and the height from the slab between them, and you see the roof one structure, and everything you can see more detail from the structure. You call that the section. So that's the difference between elevation and the section. This is explain more about that. Elevation is the image. It projects onto the vertical picture plane. That means you see the height from the building. A building elevation show vertical dimension relations. The organizational massing scale from the fenestration. The surface from the parallel to the picture plane produce for the true shape. Any surface not parallel to the picture plane will appear foreshortened in the plane. A horizontal plane cuts through the building so as to remove that part of the building above. The cutting plane, floor plane, express and communication in intent from the design as well as the feasibility of the layout. Design section normal do not show the foundation piers to reference the datum line, but rather show the tones of the solid cut, round mesh, or an edge line between sky and crown. That's the section. This is another example, so you can see that the section, if you see the house like this, you can go with the ray line or construction line to project that, and you draw the front face from the house with the slope roof right here, and you have how sloppy that's. You can measure elevation right here, and you create a line for make sure that in front face, you know, this one is the slope one. From the rear to the front face, this is the slope one. And after that, you show all the detail in front of the projects, and you call that elevation, because you see the height from on up the projects. If you cut like this, you cut through the building, and this one you can see, you know, maybe a couple feet from the house, and after that you see interior like this, and you can call this one the section cut from the building. This is elevation, so you see the projects, it's like this. Now if you go with this one, you can see this is the floor plan. The floor plan, you can see the wall, the window, and the door. You can see this is window, this is the door, and the dark one, this is the wall. And if you cut between that one, if you cut like this and you do the arrow, look at this side, that means you stay here, you look at this side. You can see the section cut look like this. And you can see that the section, you see the door right here. When you draw the project line, you can draw this one from here. From here you can draw the line, project down here, and you can draw the door right here with the height from the door. And after that, the window, do the same thing. You draw the line, project line from here down here, and you can see the height from the window. And same thing with that. This one, you see the door, the wall, and after that the door right here, you see the section cut from the door, and the roof one. So basically this one, you see everything from the floor plan, the section cut right here. When you stay here to look this one, you call that a section. And this one is the one you look at the elevation. That means you look in front of the house. You see the window right here, and the window right here also, and after that this one. So you see this one elevation, this is section, and this is the floor plan. Same thing with that, with the building. You can see this is the two-dimensional or two perspective point from the projects. You see like this, and this one is the one like I showed you before. You can cut between them to look at the section for the house like this, or you can cut in the different way, vertical, so you can see part from the house right here. You can see that this one, when you cut through right there, and you can see this one window, and this is the section. If you cut through right here, you can see this part like this. Okay, so now this is the section types. The section type, they show you same thing like I told you before, the section, that means you cut through the building and you see the structure from the building. This is insulation, this is the wall, ceiling, and after that it is the roof one, the door or the window right here, the slab right here. So you see more structure for the building, so you call that a section, and it cross section. This is the section on the side. You see the building right here, and after that you see more slope on the sides, and that's it called the section for the side plan section. More detail right here for the section. You can see more detail on insulation on the roof. You can see insulation in the wall. You can see, you know, any detail from the structure, and you call that a section. Okay, so that's why on the section vertical plane cut, you can see through the building lengthwise, longitudinally or crosswise, transversely, so as to remove that part from the building in front of the cutting plane. An elevation show relationship of the building mass to the ground plane, as well as its scale and exterior material texture, just outside for material. Reflex ceiling. Reflex ceiling plane is the image reflects into the imaginary mirror placed on the floor plane. It's usually covered for the light on of electrical tools you added on for the building. The roof plane shows the roof configuration projects on the horizontal plane. The roof plane shows overall shape and the details configuration of the roof structure. That's you call that the roof plane or the roof framing plane. Reflex ceiling plane commonly shows ceiling elements like light panel, ceiling mount, heat registers in the same orientation as the floor plane. This is from example for you can see elevation in the plane top. This is the reflex ceiling plane. You can see the light they show on here, and the other belong to electrical. They can show here also. This is elevation. You see the height from the building, the door, the roof, the wall, and this is the roof plane. That means the plane you look on the bus view, and you can see down from the building. You just see the park like that, but maybe they can be sloped like this on the roof one, but on the top view you can see it's regular like this. This is the section cut like you see before when you look at the building. For example, for the section and elevation, you can see it right here. This is the section cut. You can see more detail, and this is on the slope one, and the model from the projects. This is the projects, the previous project. This is the roof plane. Is one of this is one of the plane you can see on the top one, and it has many lines to show you the slope from the building. For example, this one you can see the ridge. The ridge is the highest one. The ridge is the highest one from the building, and after that you can see the hip is sloped down to another ridge if they have the valley on there, or they have some more slower ridge, or they have more valley or the ridge or the hip one. So all of the roof they usually have basic structure look like this. They have the ridge one, the top, very high top, and after that they have the valley, they have the hip, or they have more detail for the roof one. You can see like that. For example, this the plane on the roof one, you can see for the chimney right here, it's right there on the roof plane. You can see the chimney right here, and after that if you look at behind from the chimney is the roof top in the main one. You can see the valley with the ridge right here. It is right here. This is the roof one, and in front of the chimney you can see the corner right here. This is the hip one from that one. And after that we have another lower ridge. This one is that one. It touched with the main roof. You can see this one. And after this one you can see the long roof is right here. With the long one have the small attached in there, and you see the small attached in there. So basically it's the way how do you look at the roof on the plane and the elevation. Reflex ceiling, like I talked with you before, they show all of the lighting, and after that they can show more electrical equipment in there. Some of them they show different kind from the light in there, and you can see the panel for the ceiling panel. So all of them a different one. The light is different size also, and they have the legend right here, so you can see that and you can know what they want to design on these projects. About the floor plan, they try to present the best. If the horizontal cut is taken through on opening door, window, as well as important vertical elements like columns. Location from the cutting plane can vary, but normal range from 4 feet to 6 feet above the floor. Floor plan illustrate the location from the walls and the door, window, stair. Like I told you before, they show the wall, the door, window, the stair if they have many levels, and they have other elements below cutting plane. We need to show the direction from the floor plan. For example, north arrow for to show the north face, or the south or the east. On of direction you need to show on the floor plan. On the side plan, you should show the orientation and the location from the building. The scale, usually we use for 1/16 scale equal 1 feet 0 inches. With the engineering, they use for the scale is 1 inch equal 20 feet, or 1 feet equal 40 feet, or 1 inch. This one 1 inch equal 40 feet or 50 feet, something like that. They want to use they want to use the smaller scale to show on the paper. This is some symbol. They usually use the arrow for north. They usually the arrow like this, or like this, or like this. So many ways you can show the direction. It depends on which one you like. This is the scale. Before they use like this, for example, 0 to 50. That means from here to here is 50 feet, 100, 150, something like that. Or from 0 to 100 if you want to do bigger scale. The arrow you can use like this, simple, or you can use like this for the view or straight one. Scale you can use like this also for describe for the distance from the scale you use it. And when you draw something, remember to put the scale and direction on the drawing. The side plan is the one you show whole thing from the projects and around the projects, and it includes the topographies, lines, the landscape elements like trees or the walkways. You need to show everything on the side plan. Sectional elevation show elevation lies beyond the cut section. Now the stair can be defined as many steps with the truss and the riser. The riser is vertical one and the truss is horizontal one, and we have the distance for that. For example, the riser cannot be higher than 7 3/4 inches, and the truss one for the riser and the horizontal one you can use like 11 inches maximum. So that's why we have the rule for to draw the scale, the stair, and it should be coordinated with the floor plan. Stairway can be many steps and connect 2 or more floors in the building. For ADA, that's mean American Disability Act, they allow for maximum slope for the ramp, pedestrian ramp, 1/12 maximum. If the ramp exceeds 30 feet long, it must have intermediate platform, that landing, if they have longer than 30 feet. Some of the side plan you can see like this. It is the side plan. You see the building, you see the tree, you see those the walkway, and cover everything like this. You call that a side plan. Some of the digital side plan you can see like this, and this is the big master projects for the side plan. And in the side plan you can see the north elevation, the south elevation, the west elevation, and the east elevation. That means you see all phase from the side plan. This is some section cut to show how the light coming to the building, and you can see the small one right here. That's the scale for the people, and this is the height from the building, and they use the skyline or design some skyline to get the light inside to the building. You can see that the light coming to the building. Okay, this one is the staircase. We have many different shapes from the stair. Some are very straight, you call that the I shape. If they have look like this, you call that the U shape. And This is the stair. That's mean they connect between the first level to the second level from the building, and we need to use like this stair. Beside of I shape, this is the L shape. You look at this. This is the L shape. So we have many stairs, and after that we have the landing. This one cannot be smaller than 3 to 4 feet wide, and up to another level you like this, the landing, usually 4 to 5 feet, and this is, you call that the U shape, and the landing is double like this. And this one is the handrail and the guardrail for this one, and this is the step. They call that the spiral from the stair. Let's look like this. Let's go like this. And this one cannot smaller than 6 inches to 12 inches from here when you go for this one. And this is the pole in the center. You can see the pole right here, and after that the step up like this. They call that the spiral. We have one more kind from the stair. They call that the wider, the small in the, look like the curve, and they do in the up and upstairs. This is the model from the staircase. Go here and landing here, and you go up more. Some other one. Okay, that's all for chapter number 4, and this is some of definition you need to know before you start with assignment number 2. Assignment number 2 have 2 parts. We have draw the floor plan and elevation. I will help you. I give you information for you do for assignment number 2 later. The way how you do for the project line. When you have the floor plan, how do you draw for elevation? Okay. Thank you so much for watching, and see you next time.